Application to modelling example. An object is shot from a cannon on a planet which may well have a different gravity to Earth, in case anybody does any calculations with this function. And due to air resistance, its path is not parabolic, as we can see. The height, h in meters, at time t seconds, is given by h is equal to negative t cubed plus 3.12 t squared plus 24.7552 t plus 0.004864. The path of the object is shown on the graph opposite. The object is fired at t equals 0 and lands just before 7 seconds, as we can see here. Romeo decides to use Newton-Raphson to look for the time of landing. Romeo does not know where the route is and starts looking for it at 3.75. What happens, and how could he tell his result is not correct? After looking at the graph, he decides to start at 6. At what time after firing does the object land, correct to 4 decimal places? Well, the first thing we need is our Newton-Raphson formula. So if this is h, dh dt is this, and our Newton-Raphson formula would be Tn plus 1 is Tn minus f of Tn over f dashed of Tn. So substituting in our functions, we get this. So let's use a table, and Romeo started at 3.75, and let's iterate in exactly the way we saw in the previous example. So I set this up on the calculator so I could just keep pressing equals. And what we can see is it's gone a long way away from the root to start with. And it appears to be finding a negative value. Well, of course, the object starts flying at t equals 0. So it appears to be finding a negative root. Because that was a cubic, we only saw the portion of it from t equals 0 onwards. So there must be another root if we just graph the cubic, but of course that doesn't exist on the path of our particle. The object is fired at t equals 0, so Romeo should have known straight away that there was a problem. So now he decides that he's going to start at 6. And then we iterate, and we've seen how to do these iterations before, so we can go through them quite quickly. And as mentioned before, Newton-Raphson does tend to converge very, very quickly once it converges. So we can see that it is still changing back here, but not now. So to the accuracy of the calculator display, it's not changing. And this means that whilst this last figure may change at some stage further down the track, it's unlikely to if it doesn't stop for another couple of iterations. So we can be confident in giving this answer to 4 decimal places. So t is 6.7744 seconds, correct to 4 decimal places.